So we want to use the simple pendulum to determine acceleration due to gravity, right? So that means the g part. So we're going to use t is equal to 2 pi root L over g. And this is the relationship. I want to figure out g. So there's a couple things I need to measure. I'm going to have to measure the period and the length, right? Those are probably the two main things. We're also going to need something with a mass. It doesn't matter. Hanging objects of unknown masses could be known or unknown. It doesn't really matter. We're going to use a meter stick to measure length, and we'll need a timer. We won't need a scale. We'll need some string, I guess, to make the pendulum and something to hang it from. But, yeah. So we're going to measure the period of the oscillation. So we're going to, we'll call that T. And we'll use that measuring the timer. And then we're going to measure the length of the string. And we'll call that L. And we're going to use the meter stick for that. And now if you want to describe an experimental setup, what we're going to do here is, what we want to do is we're going to talk about oscillating it. Now with experimental designs, we've got to vary some quantities. So step one, I would probably stay here. I would be like, measure the length of the string. Attach mass. So we want to build the pendulum mass to the end of the string. And hang from the ceiling. Or just somewhere upright. Let's see. Lift the angle back. So lift the mass back while keeping the string tight, taut, and release. So make sure that the angle is less than 10 degrees or something like that. And then we're going to repeat it. Now we always have to vary something. When we want to vary a quantity, we got to vary the length of the string. So repeat. Oh, we got to measure the time. So then we're going to let it oscillate. Now it's always good to do it a few times. So let it oscillate. Okay, so actually we're going to release it and start the timer. So that's probably what we're going to do. We're going to release it and start timer. And we're going to stop the timer after, say, 5 oscillations. It's hard to measure one oscillation because it's easy to make a little mistake. It's always good to do like a few. And then now we're going to vary a quantity. We want to repeat with repeat this 3 times. And then repeat the entire thing. Repeat with the same setup. And then repeat 1 through 6 with 5 different lengths of string. And the reason we want to do that is we want to do it repeats different lengths of strings. We want to vary a quantity and see a response so we can plot on a graph, make a straight line. Okay. Include enough. Okay, so that's a repeat. Indicate. Yeah, I don't know why. Oh, it's because I actually copied it twice. Okay. Indicate the quantity should be plotted to where you get a linear curve to obtain the acceleration of gravity. So we want the slope to equal the gravity part, right? So you could. You could. There's a couple of options here. You could write this as 2 pi over square root of g times square root of L. And so you could say, this is your y variable. I want, the g to be the slope. So 1 over root g could be the slope. So then the y value would be t. And then the x variable would be everything else. Everything else would have to be the x variable, which would be, the x variable would be 2 pi root L. So that's one possibility. That would be fine. You could do that. You could also rearrange it if you wanted to put g on the numerator, so the slope would equal g. So you can then square this equals L over g, and then put g up here. This is another possibility you could do. So then you could say, well, if I want this to be m, and I always want my linearization to be y equals mx, right? That's the whole idea. Then this would be my y variable, and this would be my x variable. So it's y equals mx. So that's what I usually like to do. So the vertical axis will be L. Horizontal axis will be t divided by 2 pi squared. Okay? And then last part is how would you find the acceleration due to gravity? Is you would say the slope of this line would equal g. So the slope would literally equal g in this case because that's how I set it up. If we use this process, then you would take the slope and you'd have to do you'd have to square it, do the reciprocal, and then solve. You'd have to solve for g, right? The slope wouldn't give you g exactly; it would give you 1 over square root of g. But then you would take that slope value and solve for g. But I usually like to set it up where like the thing I'm interested in is the slope, just to so I don't have to do any extra calculation afterwards. So this you would just read the slope, and that would give you g.